Okay, looks like we're live. We will have people joining us from LinkedIn, YouTube, Twitch, X. So very excited. I'll give people another minute to join in. Thank you to our two speakers for joining us today. We'll have you guys introduce yourself in a second here, but we'll just give people a minute coming back from the holiday weekend for those who are in the States to join. Okay, it's 2 after. We can go ahead and get started. Good morning, good evening, good afternoon, wherever you are. Thank you for joining us. We have a really wonderful demo set up for you guys today, so we're very excited. I want to go ahead and give the speakers a second to introduce themselves. So Ivan, please introduce yourself.
Absolutely. Hi, everyone. My name is Ivan Radulovic. I'm a staff solutions architect with Ivan, and I'm super excited to show you Cryptowatch demo in a bit.
Thank you. Shamim, please.
Hello, everyone. I'm Shamim Rashid. I have been with DigitalOcean for the last 5 years, and I now work as a senior solutions architect. And throughout my journey here, I have focused on helping our users build and scale their cloud footprints. And today I'm excited to present along with Ivan and Nicole to show you how we are integrating Gradient AI platform to make data management even more efficient.
Great. Yeah, we have some really excited demos and some really excited overviews set up for you guys. So we'll just go ahead and get started. My name is Nicole. I am the Senior Product Marketing Manager here at DigitalOcean, been here for 2 years, and I'm very excited about today. So let's go ahead without further ado. We're going to go over DigitalOcean, managed databases a bit. We're going to talk about our Gradient AI platform a little bit within those two topics. And then Shamim will help us talk about managed databases and Gradient AI in particular. And then we will move on to the Cryptowatch demo, and then we'll have a Q&A session at the end. So please post your questions to the comments, and we'll most likely save them for the end, just as to not interrupt the demos, but we'll be sure to get to them. Okay, so let's get started. So the first question is, why DigitalOcean? In an era today where there's the paradox of choice, you might be wondering this. And it really, for us, comes down to 3 things: simplicity, scalability, and approachability. And for simplicity, I want to talk about this. We make cloud infrastructure effortless, easy to use, so that you can focus on the building part of it. We don't want you managing your servers. We want you focusing on building innovative apps with AI that can make your day-to-day tasks within your development easier. So our stats show by this. I just want to mention that we have a 30% lower total cost of ownership, and that users are able to set up their environment in owners can set up their environment in half the steps compared to other providers. So that really is a testament to how easy and how simple our platform is to use. And then scalability, whether you're just starting out or you're running a high traffic app, we grow with you and we provide you the tools and infrastructure that you need to scale your business as it grows. So again, our stats stand by this with how many droplets we have, how many petabytes of customer data, again, and 77 billion objects in storage. And then lastly, approachability. Building on the cloud should be easy. It shouldn't be daunting. So whether you're a curious developer or a C-suite executive, your success matters to us. We're here for you either way. And again, it should be built for everyone. The cloud should be built for everyone. It should be easy. It should be predictable and approachable and well documented. So that's why we offer straightforward pricing, and going back to that documentation, around 8,000 tutorials, 3,000 product documentation pieces. And then as well, I want to mention our support. offering. We offer 24/7 support with paid options, and then also we have an average response time of under 5 hours. So again, we're a reliable cloud platform. We're here for you. We're here to help you, and we're real humans to do so. And then going over DigitalOcean again, just our global footprint. We have around 16 data centers. We deliver reliable, we have 16 data centers, with the newest one being in Atlanta, and it is purpose-built for AI. So if you're interested in learning more about that, I can put the link over in the comment section. But we deliver reliable infrastructure and network connectivity all over the globe. You can see that we support over 638,000 customers, and our proven track record of uptime with SLAs and performance helps businesses scale with confidence. So take a look at some of the customers we've helped down below. And then now I just want to go over managed databases very quickly, because I know that everyone wants to get to the demo, the fun part. But today we're going to be talking about managed databases as well as Gradient AI, which I will go over in the next couple of slides. But our database offerings is here. As you can see in this slide, we offer 6 right now. MySQL, we have some relational and NoSQL databases. We have MySQL, Postgres, and MongoDB. And then you'll see that we have more specified ones, which we'll talk about Kafka specifically in the upcoming slides. But we have more popular data engines and platforms that are more suited for workloads involving caching, search, log analytics, stream processing platforms like Kafka. You'll see that we have caching for Valkey for caching workloads. And then for search, log analytics, we have OpenSearch. So if you guys have any questions, again, please put them in the comments. I'd be happy to answer them. And then going back to our AI services, we offer comprehensive cloud and AI services. So you'll see that most recently most importantly, we're going to talk about our Gradient AI platform. So, but there are a couple of pieces to that. We have our Gradient AI infrastructure, Gradient AI platform, and Gradient AI applications and agents. So this just shows you the visual of how we are a full stack cloud service, and we have all of the products and tools necessary that will complement your AI workloads to make you successful with whatever you're building. So I will save the Gradient AI talk for the demo, but I did just want to talk a little bit more about enterprise experience and database performance. So this slide I wanted to show you guys because it shows how all of our 6 database engines that we currently offer stand up against competitors in terms of performance. So as you can see here, we beat out AWS, GCP, Azure in terms of out-of-the-box performance by 30%. So this is very interesting. I wanted to include it. And then, so simply put, you can see that we outperform the nearest hyperscaler by 30%. And then the cost efficiency, as you can see in the chart to the right, is noting at 42%. So DigitalOcean outperforms the nearest hyperscaler by 42%. So this can be attributed to a lot of things, but I did just want to show this because it really visualizes how quickly we advance our database engines and how you can experience the price performance advantage with DigitalOcean. Okay. And then again, this is just some more information on our SLAs, information on where that 30% lower cost that lower total cost of ownership number comes from. If you guys have any questions, I'm more than happy to answer towards the end. Again, just mark your question in the comments, but I want to go ahead and get to the demos because I think that's, I'm really excited for you guys to see it. So I will now pass it on to Shamim. Right.
Thank you, Nicole, for the good introduction. So before we dive into the architecture, let's define what the Gradient AI platform does. So it is an advanced orchestration layer designed to turn the LLMs into functional agents. So the reason why we are focusing on integrating it with managed databases is simple, because data is only as valuable as it is accessible. And when you combine DigitalOcean's reliable data storage with the Gradient AI platform's intelligence, we move away from the manual SQL commands and move toward a frictionless conversation with our data. So let's see uh, where this works. So this is a natural question: where does this actually make sense, and why would you use it? So this approach is ideal in environments where data already exists, but access to insights is slowed down by technical barriers. So let's think about organizations where valuable data lives in databases, but every meaningful question still requires a SQL query or a dashboard update or a request like a ticket to the data team. So what we are doing with Gradient AI and managed databases is removing that friction. Instead of asking people to learn how the data is structured, we allow them to interact with it based on the intent. So you can just ask questions with your intent and you will get the information without learning how the data is structured. So there are a few common business scenarios where this becomes especially powerful. One of it is business analytics. So leaders and stakeholders in a big organization often need answers quickly. So things like trends, performance metrics, or a customer behavior, things like that, you need answers very quickly. But they might not want to navigate to dashboards or wait for reports to get this information. So natural language becomes the fastest interface there. Another one will be operational and internal insights. So think of a DevOps or a support or a platform team which frequently needs visibility to database state or permissions or system health. So with controlled function routes, they can safely inspect and validate the system without risking any changes. And the next one would be embedded or customer facing analytics. So the same pattern can live directly inside an application. So it allows end users to ask questions about their own data in real time without exposing that underlying database at all. So the key takeaway here is that this isn't about replacing dashboards or SQL. We need it, but it's about augmenting them. So we are dramatically reducing the time between a question and an answer while keeping the system secure, scalable, and easy to evolve. So that's how the combination works. So with that context in mind, let's look into how this actually works at a system level. So now looking at the system overview, we have two core pillars, which is one of it is our managed databases, which provide a structured source of truth, and the Gradient AI platform, which serves as the natural language interface. So we have a secret sauce here, which is the function route. So instead of the AI guessing how to query your data, we use a smart mapping using the functions. The agent identifies a valid function which is tied to the agent, specifically built for the user's intent. So the function executes with precision, extracting only the required parameters from the database and give the information back to the user. So as you can see in the diagram, the workflow is a very clean four-step loop. The user asks a question in plain English. The agent interprets that intent and triggers the specific function call. The database returns the raw data through the secure channel, and finally, the agent formats it into a structured answer for the user. So the user does not have to know how the data is structured inside the database. They can just simply go ahead and ask the question, and they will get the answer in the format they want. So let's see this in action. So let's look at a shop analytics use case. So I have a sample database that contains tables like customers, orders, products, and returns. And I have a couple of function routes, one for checking the database, which inspect the DB structure, users, and privileges, and another one for analyzing the data. So as I mentioned, the shop analytics database has some database information. So I mean the shop information, the information related to the product, customers, or everything. So let's see this in two point of view. So one from the internal admin point of view and one from a reviewer point of view. So first one will be like, if you see in the function root, we have a check database function. So we have the point of view of a DevOps or an internal team member. So they can use a check database route when they ask questions to inspect structure, users, or the database or the privileges. And they might ask questions like, which user has access to this DB, or how many databases you have, questions like that. And the agent uses this route to ensure the system is healthy and secure and get the information from there. And another one, the data analyst, this is something, a function which can be used in the point of view of a senior business reviewer who is not a technical but a deep but a person who needs deep insights. So this person doesn't want to see the table rows or anything technical or how it is structured, but they want complex business logic. So they can use this route. So I'll do a quick walkthrough here. So in my screen, you can see my terminal. So I'm going to show the databases I have in this cluster. So I have a DigitalOcean MySQL managed database. Uh, you can connect this gradient AI with any of the databases, but here I am using MySQL, and later in the demo we'll be using Postgres, Kafka, OpenSearch, everything. So in this one I'm using MySQL. So I have a database cluster with these databases inside. So let's see. As I said, I have a database called Shop Analytics. So let us see what it has got. So if I look at the tables, we have customers, order items, orders, products, returns, etc. And let's see how this table looks like. So I'm going to see what are the customer information. So these are the customers who signed up. So these are some dummy data I have put in. Now let's see what are the products. So I have a few products and prices listed. So similarly, I have the information about the orders, returns, etc. So now I'm coming to the gradient AI part. So creating a gradient AI agent is very easy from the DigitalOcean portal. So you can just go ahead, go to the agent platform. You can go and create an agent. So um, you can, it will ask for a few basic questions. The agent name, you can give the agent instructions, and you can select a model. And in this demo, I'm using the OpenAI model, but you have Llama, DeepSeek, Mistral, Anthropic, all these models available. So you can choose whichever one you require for your application. So you can put it in a workspace. You can add knowledge bases. So knowledge bases is nothing but some information you have about, you have the data, you want the gradient AI agent to be fetched from. So you can put a documentation link for web crawling, or you can put some information in the spaces. You can upload a file, whatever, you can use that. So this is how you can create an agent. I'm not creating one because I already created one. So this is how the gradient AI page looks like. So you can see the endpoint here. You can add an endpoint access key if you want. You can see the chatbot script, which you can put as a footer. You can get all the details here. And playground is the place where you can just try it out. You can ask questions and see if it is behaving as expected. You have observability, you have runtime logs where it will give you information on the running, and you also have an option to enable trace storage there, which will give you information on the past chats and everything, conversations and all. You can see the activities here. This is basically the changes made to this agent. Evaluation, you can do the test cases, runs, everything here. I'm skipping the settings. So settings where you can update the agent info. You can see all the basic informations, tags, agent instructions, etc. You can update the endpoint access keys, etc. And coming to the resources part, which I skipped earlier, this is where you can update the model. If you want to change the model, you can do that. You can attach or detach the knowledge bases. You can add guardrails to prevent sensitive data or content moderation, or to avoid jailbreaks. You can do that. You can add agent routes. And next is the function routes. So this is the important part. So as I mentioned earlier, we have two functions. So I have created a check database function and data analyze function. So the check database function is the one to check the database information, the point of view of an internal system admin or a DevOps person. And this data analyze is the one from the senior business reviewer perspective. So I have put it together in this one gradient AI script, but you can put it in a separate gradient AI agents, or you can update the agent instructions to how well it fits your requirement. So once you add a so before adding the function node, what you have to do is you have to define the function in DigitalOcean. So you can go to the functions part in DigitalOcean. You can write it. So this testDB function is the one that you use for checking the database. And I have this data analyze, which is used for analyzing the data information from the shop analytics database. So you can write Python, Node.js, or PHP or Go all these are supported. So whatever runtime you prefer, you can use that. You can go to the settings and change the runtime. You can update the limits. You can do the environment variables, etc. If you have a simple code, you can just directly run it in the function section. But um, if you have a function code which has multiple files, etc., you have to deploy it through the command line interface. So it's pretty simple, and you can go to this develop locally with CLI option, and it will walk you through the steps for implementing that. So once you have the functions ready, you can add a function root here, and it is easy to add one. So I'm going to the ones I have added already. So if I go to edit the function root, I can see there's a function instruction. I can mention at what time you have to invoke this function. All this information I can mention. And I can define an input schema. So it supports the Open API parameters and the JSON specific format. So we can define the parameters, the input schema there. Then we have the output schema. So these are important for getting the information back to the agent. So when you add the function for the first time, there will be a example block of code there. So you can just follow that format to modify it for your specific agent. So once the function is handled, the logic is pretty much simple. When you ask the Gradient AI agent about the question that you want, it will call the required function and gather the information. Now let's see that in action. So this is the chatbot. So I have deployed that chatbot in this app platform website. So I'm going to ask questions. So first, in the point of view of um, an internal DevOps guy. So I'm going to ask, okay, or I'll ask how many databases are there except system databases. So what it happens is it will take the check database information, the function. It will invoke that function, run the script. It will gather the information, and it will come back and say, okay, you have 4 user created databases, and these are the ones. So it will give you answers like this. You can ask more questions like which user has access to the shop analytics database. So shop analytics is the one that contains all the shop data. So if you want to understand which user has access to it, we can just simply run the query. Again, it will use the function, it will invoke the function and gather the information like this. So it says that almost all the users have some privilege to the database, and it will list everything. So based on that, you can modify the resource accordingly. And now I'm going to the point of view of the senior business reviewer. So the questions they might be asking is like, who are my top 5 customers by revenue? So as I showed earlier, there are a few customers inside that shop analytics database. So when you ask questions like this, it will gather the check database, the analyze database function. It will invoke, and it will gather the information like this. So it will see Bob Smith is the one who has spent like almost $2,700. It's a top customer. So we have the list of top 5 customers. And from the point of view of a business person who wants to understand, okay, there are a few customers who signed up, but I want to know which are the customers who never bought a product. So I can ask, okay, identify the users who have never made a purchase. Then I can ask question. It will again invoke the function and gather the information from the database and come back and say like, okay, these are the users who has never made a purchase. You can get the customer ID, name, email, etc. So you can use that for reach out. One more thing is like maybe in the product side, if you want to know which product has the highest return rate, or which is the one product people tend to return most, you can ask question like that. It will also gather the information, and it will give you, okay, USB-C hub, graphics card RTX 4070, and wireless mouse. These are the one with most return rates. Okay, so in both cases you have seen like I have never written a line of code. I can simply ask, and the agent routes the request to the correct function and get the information and come back. So from the point of view of a non-technical person, natural language is the best interface to go ahead and gather information. And let's go back to the slide deck, please. Okay. So I want to highlight the core benefits of this architecture. So we are not just building a cool tool, we are solving a few fundamental business challenges. So first, we are providing non-technical access to analytics. So when you use Gradient AI platform as the interface, it helps empower stakeholders from marketing to operations to any department. So it will empower them to get answers directly without waiting for a data scientist or a technical person to write an actual SQL query. So that's a huge plus. Second, we deliver faster insights. So because the agent uses specific function routes, it can leverage pre-computed logic to return complex answers instantly and significantly reducing the time to insight. So we already have seen that. I just asked the question, it gathered the information and came back. I don't need to decode the structure. I don't need any SQL queries there like that. So next, from the infrastructure perspective, this is scalable and maintainable, and thanks to the managed databases. So when you use DigitalOcean's managed database, we ensure the backend is robust and reliable. So it allows the AI layer to focus entirely on the intelligence while DigitalOcean handle the data's heavy lifting part through the managed database. You can also resize easily to the as the database. I mean, you can easily resize the database as you grow, which makes it scalable. So you can start with a smaller size of database. When the data grows, you can go up. And we have point in time recovery backup from the last 7 days also. Like if something goes wrong while you make changes to the database, do not need to worry. You can just restore it to the previous version, and the backup is included at no extra cost. And we have high availability options by adding standby and read-only nodes to ensure things run smoothly. And finally, the system is extremely easy to extend. So as your business grows, adding a new data source or a new analytical capability is as simple as defining a new function route, as I mentioned earlier. The architecture remains the same, but the intelligence continues to expand. So we have seen the architecture and the logic behind it, but now it's time to see how this power translates into a real-time application. So I'm now passing this over to Ivan, who is going to show you a very cool demo of these principles in action with Cryptowatch. Ivan, the floor is yours.
Thank you, Shamim. Great presentation. Um, okay, can we go one slide back, maybe? Sure. Cool. So today I'm going to show you Cryptowatch demo project, little project that we built. It's obviously POC project, so it's not production or anything, but it will show you how powerful these whole AI things can do. So it will basically simulate a cryptocurrency market surveillance system, and it will be able to also detect wash trades and also execute comprehensive analysis. So just for those who don't know, wash trade is a form of market manipulation where the same entities buy and sell to basically artificially inflate either volume or price or both. Okay, so let's see how we set this project up. So we're going to have a token symbol TKN, and it will jump 15% in a very short period of time. This is obviously caused by wash trades. Manually analyzing this is very slow, so we want to automate detection and basically flag those suspicious transactions in real time. We also want to leverage AI, so we want to run analysis and generate a report. So let's look at the stack that we're going to use in this case. So we are going to use Apache Kafka. This is our real-time ingestion engine. Kafka is the industry standard for high throughput, fault tolerant event streaming. It lets us ingest events as they happen. It can handle tens or even hundreds of thousands of events per second without dropping a single event. You can think of it as a nervous system for our little project. We have producers, which is basically our trading platform that will publish trade events to Kafka topic, and then everything downstream will consume reliably from this topic in order as the events are happening. There are no bottlenecks, no data loss. It has a built-in durability, so we can replay history if we need to. Next thing we're going to use is PostgreSQL. That's our rock-solid source of truth for structured critical data. PG is one of the most popular open source rational database management systems. It is known for its reliability, extensibility, and advanced features. This is basically where we keep our account details, entity mappings, historical balances, compliance flags, anything that basically needs ACID guarantees, complex joins, or precise querying. Last piece we're going to use is OpenSearch. That's going to be our analytics and search powerhouse. OpenSearch is another open source project. It's community-driven search and analytics engine. Was forked from Elasticsearch. Many people know about Elasticsearch. OpenSearch is pretty much the same thing, just fully open source version of it. It's designed for full text search, log analysis, observability, real-time application monitoring, and large-scale data processing. It has a strong support for distributed indexing, relevance ranking, has a vector search capabilities, and really powerful visualization with OpenSearch dashboard. And in our case, it's perfect for searching trade patterns, filtering suspicious activities, or drilling into time series metrics across millions of records. And of course, we're going to use LLMs to deliver intelligent and context-aware analysis. Okay, I think we can move to the next slide, please. Okay, so here we can see the architecture of our project. So we are going to use Terraform script to basically spin up our infrastructure, our stack. Again, I mentioned Apache, Kafka, OpenSearch, and Postgres. This is very common in production workloads. So you have your script that describes your DBaaS infrastructure, and you can see everything in that one place. It's super easy to spin up. Basically, you write a script. I'm going to show you that script in a bit. And then if you want to change something in your infrastructure, maybe scale up or scale down, add more nodes to your cluster, it's super easy to do this with one line code change in your Terraform provider script. Okay, now I'm going to show you the demo. So let's jump in here. And before I actually run a demo, I'm going to talk a little bit about the codes that demo contains. So we have a setup JS script, which is basically just a script that creates Kafka topics, OpenSearch index, and tables for our PG with fake customer data that we're going to use for the demo. Some of these things, for example, Kafka topics, you can manage with Terraform provider as well. And this is very common in production workloads. But in this case, we choose to do it in a simple script because it's easier just for us to rerun as we do the demo. The actual Cryptowatch project actually contains 3 major scripts. First script is market.js, which basically runs a market. So it will create trades, and it will connect to Kafka as a Kafka producer and produce these trades into a Kafka topic. It is also capable of generating wash trades, which I'm going to demo as well in a minute. So on demand. So basically, when we choose to, it will start doing wash trades and then stop after 30 seconds. The next component that we have is ingest script, ingest.js script. By the way, everything is Node.js, so that's the language that we use in this project. And you have the link for the project on GitHub. It's publicly available for you to download. The link is in the slides. So ingest.js script basically reads those trades from that same Kafka topic that market is generating. And as it reads those trades, it detects if the trade is a wash trade or not. And with that enhancement, it writes those trades back to OpenSearch cluster that we later use for analytic purposes. It also, since it can detect wash trades, once wash trade is detected, it also uses a Kafka producer to produce an alert in a separate Kafka topic. And this alert will be reused later with the risk worker script that I'm just going to explain actually right now. So risk worker has a Kafka consumer. It consumes for that from that alerting topic in the Kafka cluster. And as an alert comes, it means that we just detected a wash trade. It will flag in account that is involved in the wash trade as a high risk account. It will update the risk score, and it will also print out that alert on the screen. We could also, send a Slack message or a text message in real projects. This is just a demo. So that's pretty much the system as it works automatically. And then where human is involved, human will see that alert coming from the risk worker, risk engine actually, and human can then ask AI to produce a report about that account that was just flagged as risky. And then the AI will go to the OpenSearch cluster and run some queries to analyze the data. And based on that, it will collect associated account information from the Postgres as well, and then generate pretty nice report. Okay, so now it's time for demo. So first, what I'm going to do, I'm going to reset the whole thing. So Terraform, actually, I'm going to show you Terraform as well. So this is the Terraform script. As you can see, it's super simple. We just need to define DigitalOcean token that we're going to use. I'm using Toronto region in this case, and this is super simple stuff. So we just spin up a PG cluster using version 17. We also use 2 nodes, so 2-node cluster. We have primary and then secondary for failover scenarios. OpenSearch cluster, similarly, we have 3 nodes in this case, and then Kafka cluster, 3 nodes as well. Also, we need to output the connection information about our databases and put that into environment script. Okay, so now I'm going to run the demo. So first I'm going to run setup. Setup will basically recreate all the tables, as I mentioned, Kafka topics, and index in our OpenSearch cluster, as you can see here. So it will do just that. So now that we have a clean setup, as I mentioned, I didn't want to waste time running Terraform provider here. We already executed Terraform script, so 3 clusters are already up and running. Okay, so now I'm going to run market script. Market script will essentially run normal market. Right now, the price is about $100 per unit. We're also going to run the ingestion script. So this will read the market data, try to detect wash trades, and write to the OpenSearch cluster, as I mentioned. And then the risk engine here is running as well now. Risk engine is just listening for those wash trade alerts that ingestion script can detect and will produce as an alert in the Kafka topic. Okay, and the last piece, AI piece, we have 2 ways to interact with the AI in this case. So we have the one with DigitalOcean Gradient AI platform, which is basically a chat box here, and I can ask questions about the wash trades as they happened. And another thing we also have in this demo is using Gemini. So that's this agent.js script, which is doing pretty much the same thing. So it has functions to connect to OpenSearch and PG cluster. Basically, we need to explain to AI how the data structure looks for both data sources. And then we have a pretty nice prompt explaining what we need to do, and it will run the analysis. So maybe I should just do that right now. Since we don't have any wash trades, it shouldn't give us any warnings about, so we're basically asking about A12 account, and we're thinking it's flagged as high frequency, and let's see what it's going to tell. So first it's going to investigate in the OpenSearch cluster if it has any wash trades or not, and then it will collect details about the account from the Postgres database, and it will then give us the report. So in this case, it will give us a report that this is there is nothing suspicious with this account. No counterparty is linked to wash trades, etc. So, and that's the reality. Like, right, nothing is really happening with the account. So now let's run the actual wash trade. So when I press enter here, this market script will gonna start producing wash trades, and focus on the other two screens here, because you're going to see that ingestion engine will detect those wash trades almost immediately, and then it will generate that alert message into Kafka, which was going to be catched by the risk engine, and risk engine will also print the alert. So let me actually do that. So I'm pressing enter now. This will trigger wash trade sequence. As you can see, the price is now jumping high. It jumped already 14%. And here you can see how wash trades are detected. We can see the accounts that are involved in the wash trade, A12 and B77, volume and the price. And then here you can see that the alert happened. So we detected high frequency trading between A12 and B77, and we are marking risk score, or updating risk score to these two accounts to 90 and 92. And now that this is happening, again, ingestion engine will also, as it detects these wash trades, it will write those trades into our OpenSearch cluster. So these trades will appear as wash trades in the OpenSearch cluster. And now if we ask the AI, and let me just pull the good prompt, just copying pasting prompt here, it will give us details about the wash trade that just happened with A12 account, and we'll pull more information about it. So as you can see here, it also detected B77 account as a counterparty for the wash trades, and it gave us pretty nice details about the account. This is pulled from the PG database, and the actual wash trades were detected in the OpenSearch before that. Let me also do the same with the Gemini script here. So I'm going to rerun the Copilot version as well. So again, Gemini is now contacting our OpenSearch cluster, doing the aggregation, trying to find parties involved, and then it will pull the details by running these two queries from the PG database, and now it's going to create a little bit different report from the previous one. As you can see, it also detected B77, and also it pulled some deposits as well, and a very good summary here about the verdict of wash trade. Okay, the last thing maybe I want to show you, since I mentioned Terraform is super powerful. So the way we can, and this is the Terraform script I showed you earlier. So the way we can, for example, downscale our cluster to save some money, we could just say, okay, I need one node here and one node here. Save this and then do Terraform apply, and it will automatically downscale my in this case, PG cluster and OpenSearch cluster to just one node. And this will happen with 0 downtime as well. So it's that easy. Okay, and I think we're on 45-minute mark. So I'll give it to Nicole now. I don't know if we have any questions.
Yeah, I didn't see any questions, so I can just, I want to make sure that everybody is able to ask the question. So if you're live streaming and you can't figure out the question feature, just use this QR code. You can hop on here to ask a question. But a couple of things I wanted to move through. If you are not a customer, if you are not a user with us, you can head to do.co/migrate. We do migrate you for free over qualifying workloads, which is just workloads valued at $2,500 or more. So you'll be working with people like Shamim, who is a solutions architect, to help move your workloads over amongst, other people. You will get a dedicated team to your migration. So I just wanted to put that out there. And then what to do next if you're not a prospective customer, if you have, let's start this way. So if you haven't done anything with us, if you're brand new to us, then you actually qualify for credits. You can get $200 to try with DigitalOcean. So that would be the first QR code. And then the next two, if you are a DigitalOcean customer, if you already use us, if you have any questions today, or if you're more interested, you can connect with people like Shamim if you use the 2 QR codes. So get expert guidance that will lead you to our solution architect team, and then the contact sales that will lead you to our sales team if you had any questions more related to products for them. So I'll just leave this here. I didn't see any questions, so I'm going to assume that both demos made you guys experts by the end of it. So thank you two very much for coming on and sharing your wisdom and giving the demos. They were very helpful. I found them very interesting. And I believe we're done. So thank you, everyone. Appreciate it.
Thank you.
Thank you.
Everyone.